Hey, differential equations. Okay, so we are pretty much going to finish out the rest of the semester dealing with systems of equations and then some numerical methods. And for this textbook, all of their systems of equations is in lesson 31. And so we're going to start off really, really basic with 31C. Yep. So some really hand-picked differential equations where pretty much you solve one differential equation and then you plug it into the other. So this one should be pretty straightforward. Lesson 31C, definition and solutions of a system of linear first-order differential equations. So what is a system of linear first-order equations? They're a set of differential equations that are in this form. We've got, dy dx, or sorry, dx dt is some function of t times x and some function of t times y, and then, some function of t by itself. And you've got, then dy dt that has, again, some function of t times x, some function of t times y, and then some function of t tacked on at the end. And so notice these are linear, and so the x and the y's do not have any powers, but the t does not have that constraint. So the t's can have powers, but the x and the y need to have a power of 1 or need to have no power, hence linear. So the important thing to realize here is that there is no standard method is known if these coefficients are elementary functions. So let me write that down. That's important. No standard. No standard method is known if the coefficients are functions. But if those coefficients are constants, then we do have some methods to solve this. So, but if they're constants, we do. So as I said in the introduction, we're going to start with some really kind of straightforward examples, but and so these are not that difficult to do. As you get into more complicated differential equations or systems of differential equations, then there's a process to it, but they're not necessarily pretty and they do get fairly long. So let's do some really straightforward examples. I'm going to do 2 examples. The first one is number 2 in your book. So simple case. Dx dt is 3e to the negative t, and dy dt is x plus y. So notice that this one does not have any y's in it, and so we can go ahead and solve that. That's going to be what? Separation of variables. So if we go ahead and separate this, then this is going to be dx equals 3e to the negative t dt. Separation of variables says now we can integrate both sides, and so now that we do that, we'll get x here. We'll get if we integrate that, we get 3e to the negative t negative, divided by -1, plus our integration constant. Okay, and so now we can take that answer and plug it into our other differential equation. So now our dy dt would now become a -3e to the negative t plus c plus y. And we can solve this one. This one's going to now be a linear So let's get this y over to the other side to get it into the correct form. dy dt is going to be minus y is negative 3e to the negative t plus c. Our integration constant in this case, or not our integration constant, our multiplying factor is going to be e raised to the negative 1 dt, or, our multiplication factor is e to the negative t. So when I multiply that through, this now becomes e to the negative t dy dt minus e to the negative t y equals negative 3e to the negative 2t plus c e to the negative t. Okay. So remember, we're doing linear, so that means that this side is a product rule. What would our product rule be? Our product rule would be e to the negative t times y. This other side stays the same. So now we can integrate. And the integral and the derivative cancel each other out. So just on this left-hand side, e to the negative t times y equals, when I integrate this side, then I now have what? Well, negative 3e to the negative 2t divided by negative 2, plus I'm now going to make this a c1, because I'm going to get another integration constant in just a moment, e to the negative t divided by negative 1. And then I've got a second integration constant now, which makes sense, And so now once I multiply everything through by this e to the t, in order to get rid of it here, then I get y equals 3/2 e to the negative t minus c1 plus c2 e to the positive t. And so my system answer will be from above, and this is c1. Y is 3/2 e to the negative t minus c1 plus c2 e to the positive t, and x in this case is negative 3 e to the negative t plus c1. Let's do another example. This is number 4 out of your book. This is actually a system of 3 equations. So dx dt is 2t, dy dt is 3x plus 2t, and in this case, dz dt is x plus 4y plus t. Okay, so we should start with the simplest one. So because this one has only t's in it, then we should start there. So again, this is separable. If I go ahead and separate this out, we'd have a dx equals 2t dt. We can integrate both sides. And so now I've got x equals t squared plus what will be my first integration constant. So we can take this and we can plug it into the next differential equation. So now my dy dt becomes 3 times x squared, not x squared, t squared, plus my first integration constant plus 2t. I'm going to go ahead and distribute that through. Okay, let's make a note here. So here, notice I've got 3c1, 3 times my integration constant. And a lot of times in the past, we've just said that if you take a constant times our arbitrary constant, it's just another arbitrary constant. And so we can drop that coefficient. But now my C1 is a specific value, and it's a specific value that correlates to this C1 over here. And so I want to maintain that relationship between our two functions, our two solution functions. And so even though this is just another arbitrary constant, you should not change that into a different arbitrary constant. You should leave it as it is. So, okay, this is another separation of variables. So we now have 3t squared plus 3c1 plus 2t dt. And we can integrate here. We've got y equals t to the third plus 3t c1, or whatever order, plus t squared plus our next arbitrary constant. And we're going to take both of these now, and we're going to take both of them and plug them into our zt. So now our dz dt, I'll write it down here and then move it over, is x. X we said was t squared plus c1 plus 4y plus an additional t. Okay, let me mess with that now. So I'm going to go ahead and distribute that in just to make it nicer. And it looks like we can combine some things. So I'm going to go ahead, what have I got? I'm going to go ahead and combine this t squared and this t squared. And, well, I could combine this one and that one. I think I'm going to leave those as they are. So what have we got? We've got 2t squared plus c1 plus 4t cubed plus 3t c1 plus t, oh, that one was already, we already did that one, plus c2 plus t. Okay, so again, this is, because they're all in terms of t, this is another separable one, so I'm going to kind of be cheesy here. So now if we integrate that, we get 2/3 t to the third plus c1t plus no fourth, t to the fourth plus 3/2 c1t plus t squared plus c2t plus 1/2 t squared plus my third integration constant. So can I combine any of those things? I'm sure I can. Let's rewrite that. So c is t to the fourth, and then plus 2/3 t to the third. So now we've got that one gone and that one gone. Now let's look at my squareds. So my squareds, say I have plus 3/2 c1 plus 1/2 t squared So that's that one and that one. And then t's plus c1 plus c2 times t, that one and that one, plus c3. Oof. And let's see, let's remember. So y was t to the third plus 3t squared plus 3c1t plus c2, and z was t squared plus c1. So, wow. Big answer. Not really that earth-shattering, just maybe takes a little bit longer. So try a few of these. Let me know if you have problems. Oh, right. So if you want to do some homework, I suggest that the homework is on page 421. Do 1 through 7 odd. So as I said, these are going to be the simplest of the ones that you're going to find, but it is a good idea to do some practice on these. As always, if you guys have some questions, let me know.